Everyone, thanks for joining for exercise 3. As I mentioned, we're going to be expanding our application. In exercise 2, we used the data assistant, the DAQ assistant, which was super helpful for building a very simple data acquisition application and doing so interactively. It's really helpful, but doesn't offer some of the lower level control or performance that you might want on some larger or complex applications. So now we're going to go ahead and use the DAQmx VIs, which are the VIs that come with the DAQmx driver. So we're going to first begin by saving our exercise one more time. So let's go ahead and hit save as, substitute copy for original, and then I'm going to save this as exercise 3. And let's go ahead and click OK. So the first thing that we're going to be doing is deleting the DAQ assistant. So you can click and drag to create a box and then go ahead and hit delete. And you'll see all those broken wires that we just made or broke. And then you can hit Control B one more time to remove some of those broken wires. At this point, I'm going to go ahead and move this to full screen so we can really just focus on the block diagram and see everything that we need to add. So we're going to go ahead, right-click on the block diagram, go to Measurement IO, and select NI DAQmx. And let's go ahead and drop in our Create channel. And I'm going to go ahead and place this towards the top left of our block diagram. We're actually going to be adding a number of items from our DAQmx palette. So let's go ahead, and one thing that you can do is actually pin down this palette box. So that way you're able to add a number of things without having to go in every single time. So you can go ahead and add in we've added in the create channel. Let's go ahead and add in a timing function. Having trouble clicking it. Click one more time, click to place the item. Then, so we added in our create channel, our timing, our start. Let's go add in a read because we're going to be reading data. If we were generating a voltage signal, we'd go ahead and write that data out. And then now let's go ahead and stop the task and then clear it. And so this will be, and then you can go ahead and X this out so that way we can see. But this will be a pretty common structure for some of our applications that when we're acquiring data. So you usually create some sort of channel, tell it what channel or task you're trying to do, set up any timing, start the task. In a while loop, if you're doing this continuously, you're going to have the read task, and that can be within a while loop or without, depending if you want to do it once or multiple times over and over again, and then sort of our stop task. And this was all previously being done with the DAQ assistant, but now we want to do this with the DAQmx VIs, because again, we want more control, and it's sort of the best practice when you're using other devices that don't have the DAQ assistant. This is sort of the overall flow that you're going to be doing. So it's pretty helpful for you to get familiar with this using the DAQmx VIs. Now we're going to wire all of these VIs together. So if we go ahead and open up context help, we can see all the inputs and outputs of these tasks, or of these sub-VIs, sorry. And so this terminal contains the task information, which is going to be connecting all of the wires for this voltage task that we're going to be running. So we're going to go ahead and click the task out of the create channel, move that to the timing, and then move that to the start, move that to the DAQmx read, and from the read to the stop to the clear task. And then you can do the same with our errors. So if you want proper error handling, you can go ahead and wire that as well. And then if you wanted to spend a few seconds organizing this so it's removing any unnecessary wire bends, you could do that too. I know why this wire has decided to act funky, but we can go ahead, select that wire, and move it down to get rid of that. And this could also move down one. And then now we also want to add some of the labels. Since we've been doing that, we can see, let's go ahead and create the box to hover over all of these items. And let's go ahead, right-click visible items and select label. So now we can see the create virtual channel, the timing, the start task, DAQmx read, and more. Sorry, just trying to make sure everything is organized. So everything is wired. We have all the labels set properly. Let's now go ahead and set up our create virtual channel. So let's go back to the front panel. And one of the first things that we did was select the device that we're going to be using in the DAQ Assistant. And you're going to be doing that with the create virtual channel. So let's go ahead and right-click on the block diagram, go to Fuse Design System, and select I/O. And then we're going to go to Fuse Design System, DAQmx, and then go to the DAQmx physical channel. And we're going to go ahead and drop that right here in the top left of our front panel. And this will select the device that we're going to be using for our voltage acquisition. And as you can guess, this dropped it not only on our front panel, but on our block diagram as well. So let's go ahead and see that. And we can connect it to our create virtual channel. So we're going to go ahead and click to wire an output from the physical channel to the physical channel terminal on the DAQmx create virtual channel. And once again, I'm going to eliminate any unnecessary wire bends, remove the overlaps, and that's the DAQmx create virtual channel. Now let's move on to the DAQmx timing. We're going to set the sample mode first. Go ahead and go to create constant. And we're going to change this from finite samples to continuous samples. And change this samples. Now we're going to move to select the samples per channel. We're going to go ahead and click create constant. In the DAQ Assistant, we're sampling at a rate of 1,000 hertz. So we're taking 1,000 samples per channel. So we're going to do the same here. And then next for the rate, we're sampling at a rate of 1,000 hertz, and we're going to do the same thing here. So let's go ahead and click create constant. And that as 1,000 as well. Next, there's nothing really to configure on the start task, so we can move on to the DAQmx read. And now we're going to be setting the settings for this. So let's go ahead and click on this drop-down menu and we're going to be telling it the type of data that we're going to be reading, how many channels, and how many samples. So we're going to select analog input because it's a voltage input, single channel, multiple samples, and then waveform samples. And then there's not a whole lot to set up for the stop task or the clear task either. So we can leave that. And now, similar to the DAQ assistant, we have to wire the output to the time domain signal, the FFT, and everything else. So let's go ahead and create those wires. So let's wire this to the time domain signal, then to the FFT, and then to the write to measurement file. And so now we've wired everything properly. If you need to spend a few moments to reorganize the block diagram, now would be a good time to do so. But we're basically ready to run the application. I'm going to go ahead and rename, which I forgot to do, the DAQmx physical channel to voltage input. And you have to go ahead and hit and select the channel. So we're going to go to voltage in, analog input 0, and then you can change the file path if you want to exercise 3 data. And then we can go ahead and run this application to get started again. And we can see all the data that's being acquired, and we can go ahead and hit stop. I actually forgot to change a few settings, so let's go ahead and fix our graph. And so we're going to click on this time domain signal graph, and we're actually going to change it to a chart. So let's go ahead and right click here and go to replace and select graph and then select waveform chart. So rather than a graph, which will only display one item every single time, the chart will update continuously with new data points and show previous data points. So it'll show you the history and continuity of your data, which is really helpful. Let's also go ahead and edit the y-axis. So we're going to go ahead and go to Y scale, auto scale Y, and we're going to change the maximum to 5 and change the minimum to -5. And then now we'll better be able to see our data on this graph. So before it was auto scaling and filling in really quickly the data as it moved from that 5 to the -5. But now since we turned off auto scaling, we can see that, and then we can also see history with the chart as well. So that's really helpful. And I'm going to go ahead and stop this application. We're now going to move to part B, where we're going to be doing a temperature measurement. So many times, people will use LabVIEW to control not just one instrument, but a number. And one thing that's really helpful is LabVIEW's inherent parallelism that allows you to do 2 tasks at once. So let's go ahead and zoom out on the block diagram just so we can get a better view. And you can zoom in and out using Control plus or minus. And let's go ahead and select all of our code that we've created. So we're going to go ahead and type Control A, and then Control C, and then Control V to paste. And while everything's highlighted, you're going to want to go ahead and drop this down into another loop, or you're going to want to move this below the first set of code that we had. And then you can go ahead and hit view actual size, Control 0, just so we can see everything at once, or in a better view. In the second loop, we're going to go ahead and delete the FFT power signal, the frequency domain and signal 2, and the write to measurement file. For this, we're only going to be analyzing the top row, but we just still want to be able to view the data. So let's go ahead and hit delete. You create a box to select all of that code, or you can do it individually and just select delete. You're also going to want to delete this second stop button. We'll be talking more about stopping two parallel processes, but for right now, just hit the stop button, delete the stop button right there, and then hit Control-B to remove those broken wires once again. I'm going to go ahead and label these while loops, so that way it's a little easier for us to communicate between the two loops. So click on this while loop, and then click on visible items, and then go to subdiagram label. And then now we're going to do voltage acquisition. And then we're going to go to the second while loop below, go to visible items, subdiagram label again, and then do temperature acquisition. And so we've added these labels, and now we're going to go to our front panel to make sure we have that all set up. So let's go to our front panel. And here we can see the newly pasted voltage input 2 that we added from the block diagram. And you can go ahead and move that down below the first voltage input. And let's rename that from voltage input 2 to temperature input. We also have the time domain signal graph too that we need to change. But let's find that on the front panel. If you ever can't find an item from your front panel to your block diagram, you can double click on that item in one area to open it in the second. So I'm just going to do some quick side scrolling to figure out where we are in relation to the others. And then you can go ahead and move that item towards everything else. So I'm going to resize some of these items so it all fits. So I'm going to make them a little bit shorter. And then I'm going to rename some of these items as well. So the time domain signal graph, I'm going to name that voltage. I'm going to rename the frequency signal graph to voltage FFT. And then I'm going to rename this last graph, which I actually did create overlap, to temperature C. And that completes sort of this front panel editing of ours. So now let's go back to the block diagram. And here, one of the first things that we did was edit the virtual channel. But rather than doing a voltage input, we're actually going to be doing a temperature input. So we can go ahead, select this dropdown, and change it from a voltage to thermocouple measurement. If you click on context help, you can see that there are a number of inputs and outputs that we haven't set, and we're leaving them to default because we're just using simulated data. But if you had a cold junction source, units that you wanted to specify, and a lot more, you could set those here as well. We're going to change our sample rate from 1,000 to 10, or the number of samples from 1,000 to 10, and the sampling rate from 1,000 hertz to 10. And we can go ahead and leave that there. And we're good to leave the DAQmx read VI as is. But as I mentioned, we have a problem because we have two processes running in parallel. So one thing that we can do is we could have two stop buttons, which is what we had originally, but that's kind of annoying as you need to hit stop button 1 and stop button 2 to then do that. So one thing we can do is create a variable that'll read the data from this stop button and add it to this loop right here. So let's go ahead and right click on our block diagram, go to data communication and select local variable. And we can go ahead and place that in the temperature acquisition loop. If we click on this, we'll select the variable that we want to select. And we have a few things, but we're going to go ahead and click stop. Right now, it'd be currently writing data, but let's change this to a read. And let's go ahead and wire this to that loop condition terminal right there. Now, let's go ahead and get ready to run this application. Once again, as you notice here, our code tells us that there's an error and we can't run the application. If we click on it, it'll go ahead and tell us that the Boolean control cannot use the latch mechanical method. And that's referring to the stop button. With this local variable method, we're unable to use a latch method. So, and what that actually means is, so if we're to click on the right click on the stop button, we can see a mechanical action. And what this does is actually the button presents a variety of ways of a mechanical action that it physically imitates. And right now it's using a latch when released. Let's go ahead and do this as a switch when released. And we'll be able to see the change better. And it'll now allow us to run it because that previous method could potentially create an issue when the application is running. I do want to mention that the local variable method is a very simple method to stop these two while loops. There are more robust ways to stop parallel processes in LabVIEW for more complex applications, but the local variable is a good simple way for this simple demonstration. So we're now able to run this application. We have to change the voltage in to temperature, to the temperature channel. And let's go ahead and configure the y-axis one more time. And we already see that auto scaling is off, which is good. And then we're going to change the minimum and maximum from 100 to -100. And we can go ahead and run this application. And you can see easily the different rates at which these loops are running, but we're still able to acquire both these loops in parallel, which is really great for seeing our application run. Or having two things run at the same time, sorry. You know, we're able in this application to see both applications run at the one time. So rather than having two applications that are running separately, where we need to, open separate windows, we're able to view this all in one location, which is super convenient. And then if I go ahead and hit stop, it'll go ahead and stop that application. When I hit stop, it had left this, so just make sure that you click it again, so that way it turns black from gray to blue, and you'll be okay. We're going to, and that concludes part B of this application. So we're able to add in one other measurement type. Another common thing that people want to do is add a user notification or an alert. So let's say if we're running, this application for the temperature and we want to be alerted if the temperature is too high. We could constantly be checking the graph to see if it exceeds, but having like a light blink or flash to let us know that it's exceeded is probably a little bit easier than having to check very closely every time. So let's go ahead and create an alert if the temperature has exceeded a certain threshold. So let's go ahead and click on the block diagram. We're going to go to waveform, and then we're going to go to analog waveform, and then min and max. And we're going to go ahead and place that into the temperature acquisition while loop. Once again, you can right click and select the label so that way we can view it. And you're going to wire the input from the waveform to the readout of the DAQmx read. As I mentioned, we want to know, and this will grab the minimum and maximum amount of the waveform that we're reading. So we're going to go ahead now and grab the comparison function. So we're going to go and grab a greater because we want to know if a temperature has exceeded a limit. And we're going to wire that from the Y maximum to the input on this greater function. We could set up and create a constant here. So if we always knew that it wanted to be, above 50 or above 0 or negative 25, we could create a constant here. But if we wanted that to change based on the day or the weather, we're able to set that as a control on the front panel. So let's go ahead and move back to the front panel, where we're going to right-click, go to Fuse Design System, and select Numeric, and select Horizontal Pointer Slider. And you can go ahead and use the resizing handles to resize it. You can change the name from Horizontal Pointer Slider to Temperature Limit. And then you also want to add the light that's going to flash once this has exceeded that limit. And so let's select here Fuse Design System, Boolean, LED light. And then you can use the resizing handles to make this a little bit bigger. I don't need it to be excessively large, so we can just leave that as is right there. And we can rename this to warning because we want to be warned. We can change the minimum and maximum of the sliding scale from negative 100 to 100 one more time. So that way we can set it anywhere along the range of our temperature. I want to change the weight function as well on my temperature acquisition. So let's set this to 1000. And I was about to get ready to run this application, but then I realized that there was an error, and that's because we need to wire the warning and the temperature limit. So let's go ahead and wire this warning to the output of the greater than function and the temperature limit to the other limit of the other input of the greater than function. And now we can see that the broken arrow has gone away and we're now able to run this application. So let's go ahead and try this. And we can see as the data goes, once it goes back up, we'll see that it will light up the temperature warning, and we've completed this third part of the exercise. As I wait for that to go, I just want to mention that this concludes part C of our exercise 3. I hope you were able to learn more about adding, more measurements to your LabVIEW application, learning about the DAQmx VIs. as I mentioned, these are, common process is a common architecture for programming in LabVIEW, and we are able to see that between the voltage acquisition and the temperature acquisition, our flow is exactly the same. We just had to modify some of the virtual channel and timing settings to change for our temperature acquisition. And if you stick around for the next part, we're going to be doing some enhancements to our user interface so that way it's even more user-friendly. Let's go ahead and get started with that. So if you go ahead and hit stop, we can stop our application. Depending on who's going to be using your application, it might be useful to spend some time organizing your user interface, especially if you're sending this to a colleague or a technician. You want to make sure that they have an easy understanding of your application and what exactly they need to use and select. So we're actually going to be enhancing this user interface to look exactly like the cover of the hands-on guide. So one thing that we can do is title our application, and you can create a label, a free label, by double-clicking on the front panel. So you can go ahead and type in LabVIEW hands-on to start typing that free label, and then you can move and resize that as needed. We can use the text settings to change the size, color, style of it. We're going to go ahead and make this 36. So we can see that it's pretty large. And we're just going to leave that centered up top here. You can start typing to add in a new free label. Another section that we might want to indicate is, the temperature input and voltage input. So we might want to leave that as hardware settings. So let's go ahead and write hardware settings. And then once again, I'm going to go to the text settings, select the size of 24, and then I maybe also want to have it bold, so I could change the style to bold. I'm going to select both items and move them down to create a little space. And I'm also going to move these down to create some more space. And you can either drag those or use the keyboard. Sometimes I find the keyboard a little bit easier, but whatever works for you. So now you can double click to start typing once again, or you can just copy paste one label. Again, I'm just going to copy paste it so that way I don't have to select the size and the settings all over again. So I'm going to change this from hardware settings to temperature warning. Move that down to create some space. And I'm going to move these up to be better aligned with that. And then the last label that I want to create is file settings. Go ahead and paste that. And then I'll set that to file settings. And I'm going to go ahead and move this path a little bit down so I don't have to worry about that either. If you wanted to separate the sections, you can find more decorations and ways to organize things by right-clicking, going to Fuse Design System, and going to Decorations. So here we have lines that we can add to separate some of the sections. So I'm going to go ahead and add a horizontal line. I want the line to be, exactly the same size. So if I select it, I can copy and then now paste it. And I can move that to separate the temperature and the file settings. And I kind of just wanted to try equalizing everything, so I can do that there. And let's move kind of everything down a little bit. So that way now everything is kind of better aligned. If you don't like this gray or anything, you can also add a box to create some different color. So I'm going to go ahead and add in a flat box, just so this adds a little bit of contrast. So I'm going to go ahead and resize this box to cover basically everything in my application. And then similar to how you would organize a stack in PowerPoint, you would go ahead and reorder this. So you're going to go to the reorder button and select move to back. And that'll move everything up above it. I kind of want some more space between the LabVIEW hands-on and that. And there we go. So as you can see, everything's kind of a lot more clean, a little bit more organized. If you wanted to align things, you can use the aligning objects. And you can also center things or create space to distribute objects. But I think right now we're pretty good. And that concludes exercise 3. So I hope you all were able to learn more about, setting up acquisition with multiple tasks and multiple devices, and also get some of the basics of LabVIEW. So I hope this set you up for success on your LabVIEW journey, and reach out if you have any questions or let us know how we can help. Thank you.